Welcome to the channel, data enthusiasts. In today's video, we're diving into some of the most important and frequently asked PySpark interview questions and answers, from beginner basics to advanced real-world scenarios. Whether you're preparing for a job interview, brushing up your skills, or just exploring how PySpark powers big data systems, this video will give you the clarity and confidence you need. So grab your notebook, hit that like button, and let's start mastering PySpark, one question at a time. Question 1. What is PySpark? PySpark is the Python API for Apache Spark, an open-source distributed computing system. It allows Python developers to harness the simplicity of Python and the power of Spark to process large-scale data. Question 2. What are RDDs in PySpark? RDD, Resilient Distributed Dataset, is the fundamental data structure in PySpark. It's an immutable distributed collection of objects that can be processed in parallel. RDDs support two types of operations: transformations and actions. Question 3. What are data frames in PySpark? Data frames are a distributed collection of data organized into named columns. They are similar to Pandas data frames but optimized for large-scale data processing using Spark's Catalyst Optimizer. Let's talk about one of the most commonly asked PySpark interview questions. Question 4. What is the difference between RDD and data frame? RDD, or Resilient Distributed Dataset, is the foundational data structure in Spark. It offers low-level control over your data and operations. You work with it using functional programming constructs like map, filter, and reduce. It's super flexible but requires more lines of code and deeper technical understanding. On the other hand, data frame is a higher-level abstraction, similar to a table in a relational database or a data frame in Pandas. It provides a declarative API, meaning you just define what you want, and Spark takes care of how it should be executed, thanks to the powerful Catalyst Optimizer under the hood. In terms of performance, data frames are generally faster. Why? Because Spark can apply automatic optimizations on them, which it cannot do with RDDs. In short, if you need fine-grained control or want to use custom functions, go with RDDs. If you want cleaner syntax, better performance, and easier integration with SQL, data frames are the way to go. Moving to question 5. What is the Catalyst Optimizer in PySpark? The Catalyst Optimizer is Spark's built-in query optimization engine. It works behind the scenes to analyze, optimize, and transform your query plans into highly efficient execution strategies. When you use data frames or Spark SQL, your queries are converted into logical plans. The Catalyst Optimizer then applies a series of transformations, like constant folding, predicate pushdown, and column pruning, to create the most efficient physical plan. In simple words, Catalyst Optimizer takes your code and rewrites it in a smarter, faster way, helping Spark run your jobs with maximum performance and minimum resource usage. Question 6. What is the difference between map and flat map in PySpark? This one is a classic. The map transformation takes each input element and applies a function to it, returning one output per input. So, if you pass 5 records, you get 5 transformed records back. On the other hand, flat map can return 0, 1, or many outputs for each input. It flattens the results into a single collection. This is especially useful when each record might split into multiple items, like splitting a sentence into words. Think of it this way: map transforms, flat map transforms and flattens. Question 7. Explain lazy evaluation in PySpark. PySpark is lazy by design, and that's a good thing. When you write transformations like map, filter, or select, Spark doesn't execute them right away. Instead, it builds a logical execution plan, waiting for an action like show, collect, or write to actually trigger the computation. This is called lazy evaluation. Why is it important? Because it allows Spark to optimize the entire workflow before execution, minimizing data shuffling and improving performance. So, lazy evaluation equals more efficient pipelines plus faster execution. Question 8. How does caching work in PySpark? In PySpark, caching allows you to store intermediate results in memory so they can be reused without recomputing. When you use the Dart cache or Dart persist method on a data frame or RDD, Spark stores the data in memory across the cluster nodes. Why is this helpful? Imagine you're running multiple actions on the same dataset, like counting it, showing it, and writing it. Without caching, Spark would reprocess the data every time. But with caching, Spark computes it once, saves it, and reuses the result. This boosts performance significantly, especially with large datasets and iterative algorithms like machine learning. Just remember, cached data takes up memory. Use it wisely. Moving on to question 9. What is a broadcast variable in PySpark? Broadcast variables are used to efficiently share small, read-only data across all nodes in a Spark cluster. Let's say you have a small lookup table that needs to be used with a massive dataset. Instead of sending this small table with every task, which is inefficient, Spark sends it once to each node using a broadcast variable. This minimizes data shuffling and improves join performance drastically. You can create one using Spark context broadcast data, and when it's broadcasted, each task can access it locally. No need to send it over the network again and again. Question 10. How do you handle skewed data in PySpark? Data skew is when some partitions have way more data than others. This causes certain tasks to run longer while others finish quickly, leading to bottlenecks and poor performance. Here's how to handle skewed data. Sorting keys. Add a random suffix to the skewed key, distributing data more evenly. Broadcast joins. If one side of a join is small, broadcast it to avoid expensive shuffles. Repetitioning. Use Dart repetition to redistribute data before heavy operations. Custom partitioners. Fine-tune how your data is split based on domain knowledge. Always analyze your job's DAG or use Spark UI to spot skewed stages and apply the right strategy. Now let's move to some advanced questions. Question 11. Explain the concept of shuffle in PySpark. In PySpark, shuffle is the process of redistributing data across partitions, often triggered by operations like joins, group by, or distinct. Think of it like this. When Spark needs to bring data with the same key to the same partition, it moves data around the cluster. This movement is called a shuffle. Shuffling is expensive. It involves disk I/O, data serialization, and network traffic, which slows down your job. That's why minimizing shuffle is a key part of optimizing PySpark performance. So when you write transformations, always ask, is this causing a shuffle? Can I reduce it? Question 12. What is the difference between group by key and reduce by key? Great question. These two look similar but behave very differently behind the scenes. Group by key groups all values by key and then sends all the data with the same key to a single reducer. This can cause data skew and high shuffle costs, especially with large datasets. Reduce by key combines the values locally on each partition first, then shuffles the reduced data. This means less data is shuffled, making it more efficient. So, when possible, use reduce by key over group by key. It's usually faster and more scalable. Question 13. What is window function in PySpark? Window functions in PySpark are powerful tools used to perform operations over a subset of rows, defined by a window specification. Unlike group by, which collapses data into one row per group, window functions preserve the original number of rows and allow calculations like running totals, ranking, like row number or dense rank, moving averages. You define a window using window partition by order by and then apply a function over it, like row number or sum. They are essential for time series analysis, deduplication, and advanced aggregations, especially when order and context matter. Question 14. How do you debug a PySpark job that failed in production? Debugging a PySpark job in production requires a systematic approach. Start by checking the Spark UI, especially the Stages and Tasks tabs. Look for failed stages, and drill down to the executor logs to find the root cause. It could be anything from out-of-memory errors to bad data formats. Also, examine the stdir and stdout logs. They often contain detailed Python exceptions or traceback info. Use logging in your PySpark job instead of print statements. Libraries like log4j or Python's built-in logging module help you track where things go wrong. And don't forget, keep your jobs modular. The more reusable and testable your code, the easier it is to isolate bugs. Finally, if the failure is related to data issues, tools like data validation, schema enforcement, or even a dry run pipeline can prevent bad records from crashing your job in production. Question 15. Have you worked with structured streaming in PySpark? Yes. Structured streaming is Spark's modern way to handle real-time data processing using the same data frame API you already use in batch mode. The beauty of it is, you write your streaming logic just like a batch query, and Spark handles the continuous computation in the background. Structured streaming supports exactly once guarantees, watermarking for late data, windowed aggregations, and integrations with sources like Kafka, file systems, sockets, and cloud storage. For example, you can stream logs from Kafka, do real-time aggregations, and write to a data lake or dashboard, all in PySpark. So if you're working on real-time analytics, fraud detection, or alerting systems, structured streaming is your go-to framework in PySpark. Question 16. What is the difference between repetition and coalesce in PySpark? In PySpark, both repetition and coalesce are used to change the number of partitions, but they serve different purposes. Repetition increases or decreases the number of partitions and performs a full shuffle of the data. It's useful when you want a more balanced distribution, especially after filtering or joins. Coalesce is used to reduce the number of partitions without a full shuffle. It simply combines adjacent partitions and is much faster than repetition when going from more to fewer partitions. So remember, use repetition for balancing, while use coalesce for optimization and performance when reducing partition counts. Question 17. What are accumulators in PySpark? Accumulators are variables used for aggregating information across your Spark workers, like counters or sums. For example, you can use an accumulator to count bad records, or track the number of null values during transformations. They are write only to the executors. The driver can read their final value after the job completes, but not during execution. While useful for debugging or monitoring, be careful not to rely on them for logic. Since tasks can be retried, you might end up double counting if not used properly. Question 18. What is PySpark UDF and when should you use it? A user-defined function, or UDF, lets you apply custom logic in PySpark by writing Python code for transformations that aren't built into Spark. Example, if you need to format strings, mask sensitive data, or apply complex logic, a UDF comes in handy. But here's the catch. UDFs don't benefit from Spark's Catalyst optimizer and run slower than native functions. So always prefer Spark's built-in functions, and only use UDFs when absolutely necessary. Question 19. What are data frames and datasets in PySpark? In PySpark, a data frame is a distributed collection of data organized into named columns. It's like a SQL table or a pandas data frame, and supports powerful SQL-like operations. Datasets, on the other hand, are available in Scala and Java, but not in PySpark. They offer type safety and compile time checking, which PySpark skips because Python is dynamically typed. So in PySpark, you mostly work with data frames and RDDs, not datasets. And that wraps up our list of essential PySpark interview questions. We covered concepts like RDD versus data frame, Catalyst optimizer, lazy evaluation, broadcast variables, shuffle, structured streaming, and a lot more. If you found this video helpful, don't forget to like, subscribe, and turn on the bell icon so you never miss future uploads on data engineering, big data tools, and tech interview prep. Got questions or want a part 2 with even deeper topics? Drop your thoughts in the comments below. Thanks for watching, and until next time, keep learning, keep building, and keep crunching data like a pro.